After knowing your glass fiber, alright, let's talk about the aramid fibers. Alright, so just a map. Alright, we are still on the fibers. Alright, we haven't gone into fabrics yet. Alright, so let's continue. So the fibers itself for the aramid, alright, what makes it strong is talking about the covalent bonds. The bow line being drawn very boldly is a covalent bond. Covalent bond is known to be very strong, alright, which means that it has a high modular strength, alright, things like that. And as you can see, it is strong in this direction, alright, it's strong in this direction but weak in this direction, you see, O and H. So this is a hydrogen bond, I think, yeah. So it's a hydrogen bond, H and O. So hydrogen bond layer by layer, alright, is weak, but for the longitudinal over here, this is actually quite strong. Alright, so this is the aramid fibers. This nature of the Kevlar, which is anisotropic, actually have a very poor compressive properties. Alright, where this can be reflected all the way back to the graph that I shown you earlier in previous videos. Alright, where we have this chart. Alright, for compressive, as you can see, aramid is actually very low over here, as you can see. For tensile, aramid is pretty good. Alright, if you were to compare, aramid is over here. This is for compress. For tensile, aramid is over here. It's much higher, alright, for its properties. So aramid applications mainly on tensile. Don't put it for compress. If you put it for compress, then you are killing yourself, right? Next question is, why under compressive load, alright, the Kevlar is weak. Alright, it's because after you compress it, the fiber develops a keen bands. Alright, this means that over here, this picture will explains to you. Alright, as you can see, this is a keen band. Alright, so what it do is that you have this particular thing, and then it bends over here, and it bends even. So at first it's like this. Alright, after you compress it, you will bend in this manner. Alright, the more you bend, you actually crack easily, as you can see. Alright, so this is what it's trying to say. Alright, lead to ductile failure. Alright, and why is it ductile failure? It's because if you were to think about it, if you were to bend it now, alright, so initially this is the straight line over here. If you were to bend it, it will become like that. Alright, so eventually this means that you are trying to pull in this region. You see, so this curvature region is being stretched, or in other words, this word stretch. So over here it experiences a very ductile system, where this ductile over here will actually cause ductile failure. So over here it stretch and it will break, and picha. So over here it breaks, picha. So it will become two piece, like something like this. So it will break. So this material will break somewhat. Hopefully you get what I mean. And therefore this is why it says that it's a ductile failure. And take note that I may be wrong lah, okay? But nonetheless, let's carry on with this. So I'll just highlight the keywords you can just ownself say is advanced performance in design flexibility for this type of version. For this type of K29 version, same tensile properties as this dude over here, alright, and its applications are all this. Alright, you can just check it out lah. Alright, and the next thing is that many deniers and finishes, and the next words is yawns. So what are all this? The aramid is made into this type of yawns, meaning strips of all these things. Alright, and therefore it is being made into ropes, cables, everything, and even your helmets. Alright, and the next things is deniers and finishers. So what are those? Is denier and the finisher. For denier is like SI unit like that. Alright, so it's a measure of the linear mass density of the fiber. Alright, in other words, the SI unit is grams per 9,000 meters. Alright, so I don't know why 9,000, but this is the meaning for denier. It's an SI unit. So what about finisher? Alright, so finisher is not SI unit anymore. It's called finishing, I think, and it's convert the woven or knitted cloth. So it's in terms of the yarn. Alright, and you actually bleach or dye it for multiple layers, and it says with many deniers and finishes. So so in other words, this product, alright, contains many a lot of grams per 9,000 meters, because it's SI unit, alright. So it is somewhat a lot of materials put together, alright, so rows of them put together, and then you finish them off by some dye or some protection layer and things like that, I think lah, okay. At least you get some meaning and as for the last version, for over here, this is the same thing, alright. And the next question is, they have the same application of this and this, then what is the difference between them then? So this is the inventor of Kevlar. It's a girl, it's a auntie. So yeah, cool. Inventor of Kevlar. Wow. Difference between K29 and K100 is that there is a color version of Kevlar. That's all it is. So if you want a lot of nice color, then you use this one. Otherwise, if color is not important, you should use K29. Alright, so these are the difference. If you want to watch, you watch the video over here. Alright, and the rest I think you can own self read already. But the word denier seems like a something. It's not SI unit anymore. It's like adjective to describe the fibers. So I search again. So I think it's trying to say that still a denier is a unit of measurement, is a SI unit, and a 50 denier fabric or fiber is considered heavier. Alright, I don't know where's the word heavy. Just now I see. Yeah lor. So a very light yarn, meaning a row of threads of this is a yarn. Alright, so yarn can be made into 100 denier. Alright, and a narrower diameter than say 50 denier Kevlar, and it's relatively heavy. So I think it's trying to say that 100 denier, the higher it is, the heavier it is, things like that. Alright, so with finer denier fiber, so this means that if it's finer, this means that it's going to be heavier. Alright, because over here can be spun into 100 denier and be a narrower diameter. Narrower diameter means that your diameter is smaller, I believe. So with a smaller diameter, you kind of compact everything together, alright, which is, oh okay. So I think the lower, I don't know, can be spun into 100 denier and be a narrower diameter. So I think the lower the value, because it says that it can be spun into 100 denier and be a narrower diameter, say 50 denier, which is a relatively heavier fiber. So in this case, I would think that the smaller the value it is, the heavier it is, I think. Let's try to think about it, because I just realized it's somebody's comments, alright, it's not the actual one. Alright, so depends, because if you think about it, a denier is a unit, 1 gram of mass per 9,000 mass. If it's 50, then it's 50 gram per mass, and things like that. So I think it all depends on it. But anyway, so the finer the wool, the more yarn and the higher the count. So I would assume that the finer your thread, alright. So if I were to the thread of a diameter, the diameter of a thread, alright, is very fine, is very small compared to this thing, alright. Then you could grind up more of the materials, alright. So you can have more materials within it, alright. But nonetheless, it will be slightly heavier, but at least the resolution is more fine. This is like a helmet. So if you have a very fine layer of Kevlar wrapped all around, alright, it will be very hard, alright, but nonetheless it will be slightly heavier, because you are taking a lot of wool, or a lot of wool or yarn. Let's say this is the row of yarn, where this is all your fibers all along. So you're taking a lot of, because it's very small, so you're taking a lot of this type of yarns and mix them together and weave them together to have this helmet. So the finer it is, the better it is, the stronger it is lah. So I think this is very strong, very tough, or I can tank a lot of stress, impact, or whatever. Alright, and for the Kevlar section, and yeah.